Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 4.1, which is going to deal with angles formed by intersecting lines. Now, today's lesson, section 4.1, is our introduction to Unit 2, and it also kicks off Module 4. So, for today, we have one learning goal, and our learning goal is you will be able to identify and use the properties of vertical, supplementary, and complementary angles to find the measure of angles, or the value of a variable. So we're going to go through and talk about what vertical angles are, supplementary, and complementary angles are. So with that said, let's go ahead and get started. Our kind of prelude before we get into the examples. So our pre-example is given that the measure of angle 1 is 120 degrees. We want to find the measure of the other three angles and the following situations. So, first of all, I know that angle 1 is 120 degrees. So the idea would be if I took a protractor, measured it, it would equal 120. And then it wants me to go through and find the measure of the other three angles. So there's a couple ways we could do this. We could pull out a protractor and figure it out. Or the other way is if we think all the way back to Module 1. And we talked about when two angles form a straight line, a linear pair, that means that they add up to be 180. So if we keep the idea of a linear pair, let's first look at trying to figure out the measure of angle 2. So if I ignore angles 3 and 4, if you notice angles 1 and 2, these two angles form a straight line. That means that angles 1 plus 2 should equal 180. If I already know that angle 1 equals 120, then what should angle 2 be? All right, as you're thinking about it, okay, I need angle 2, whatever I find it out to be, that needs to be added with 120 to equal 180. So if we think 180 minus 120, we would end up with the measure of angle 2 being 60 degrees, because 60 plus 120 is 180, thus my straight line. All right, next, if I need to find the measure of angle 3, again, let's carry the same idea. But let's focus on angles 2 and 3. So if I know that angle 2 is 60 degrees, what should angle 3 equal if I need these two to add up to be 180? So 60 plus what equals 180? Well, if you're following the pattern, angle 3 is going to be 120 degrees. And then if I carry the same thing for angle 4, let's use angles 1 and 4. So if I cut out 2 and 3, so angles 1 and 4 form a straight line, like we saw for the other two situations. So because these form a straight line, that means they need to add up to be 180. If angle 1 is 120, 120 plus what equals 180? And in this case, it's 60 degrees. So, I know that angles 1 and 3 are 120, and that angles 2 and 4 are 60 degrees. So, what we just did with that slight exploration is discover a pattern that when I have two straight lines that cross, the angles that are opposite of each other, so in this case 1 and 3, are the same measure. They're both 120. And then these angles are also opposite of each other, 2 and 4. They equal 60 degrees. So that is going to be our thing for vertical angles. And vertical angles are super handy and super helpful throughout this lengthy unit that covers 5 modules. So keep vertical angles in mind as we move forward. But vertical angles state this, and I'm going to kind of break this down into more layman's terms. So what this states is vertical angles is when you have two straight lines that intersect. Okay, so these two straight lines intersect. Opposite angles, angles that are on opposite sides of each other, so 1 and 3 and 2 and 4, are congruent to each other, which means they are the same measure. So angle 1 is equal to angle 3, 2 is equal to 4. And that's what this whole thing is saying. And then, if we kind of move into a little bit more breakdown of it, the vertical angles theorem states if two angles are vertical angles, then the angles are congruent. So I have my two straight lines that cross. Opposite angles are equal to each other. So 1 is congruent to 3, and 2 is congruent to 4. So opposite angles are equal. So 1 is 3, 2 is 4. All right, so we're going to use the vertical angles theorem as we go through our notes now and try to help us to solve for example 1. All right, I'm going to move this up a bit, but also try to keep part of our theorem there. All right, example 1 says use the vertical angles theorem to answer the following questions. For example 1a, cross braces help keep the desk post straight. Find the measure of each angle. So we want to find the measure of all the angles they give us here. We already know that this angle is 146, so we need to go through and figure out the measure of angle 5, 6, and 7. And that's going to be the angles formed by the braces for the deck post. All right, so I'm going to set up as measure of angle 5, measure of angle 6, and measure of angle 7. So we need to go through and find these three angle measures. We're going to use the vertical angles theorem and linear pair theorem for today. All right, so let's find the measure of angle 5 first. If we discard or disregard angles 6 and 7, okay, angle 5 and the measure of 146, these form a straight line. And like we talked about up above, okay, a straight line means that the two angles add up to be 180 degrees. So what plus 146 equals 180. So really what we're going to do here is 180 minus 146. And if we do 180 minus 146, we get 34 for our number. So that means if angle 5 is 34 degrees, we do 34 plus 146, that adds up to be 180, meaning I have my linear pair in my straight line. So the measure of angle 5 is going to be 34 degrees. All right, from here, all I'm going to use is vertical angles. So if we look at the measure of angle 6, so angle 6 is right here. We're using vertical angles. What is the angle that is opposite of angle 6? So if we have 6 here, I have two straight lines that cross. Opposite angles are equal. So the angle opposite of 6 is 146 degrees. These two angles are congruent to each other. So that means the measure of angle 6 is 146 degrees. And if we look at angle 7, its vertical pair is angle 5, because these two angles are opposite of each other. So that means they're equal. If angle 5 is 34, that means that angle 7 is also 34 degrees. And that is the measure of each of the angles. All right, so that is how we're going to go through and use the vertical angles theorem based off a diagram to find the measure of each of the missing angles. All right, for part B, for example 1, it talks about the measure of two vertical angles are 58 degrees and 3x plus 4 degrees. And they want us to find the value of x. Now, vertical angles means that they are equal to each other. So because they are equal to each other, okay, that's what vertical angles is going to imply. That means I take my 58, my 3x plus 4, and I set them equal to each other. Vertical means they are equal, so we just take these two parts because they tell us they are vertical angles, and we set them equal. So you're going to go through and use your algebra skills to solve for x. So we subtract 4, we get 54 equals 3x. And then divide by 3, we end up with x equaling 18. The reason why x equals 18 is because we do 54 divided by 3. All right, so example 1 kind of guided us through using vertical angles. We go through and find the measure of angles or the value of a variable. But there is one more part for example 1, it's part C. And what this part is going to ask us to do is similar to part B, where they tell us the measure of two vertical angles are x plus 3 and 2x minus 7. Find the value of x and each angle measure. Again, vertical angles implies that they are equal to each other. So if they are equal to each other, we're going to take these two expressions, x plus 3, and set it equal to 2x minus 7. Now, I'll let you go through and solve that and practice kind of your solving skills. If you do want to know what x equals, you should get 10 to equal x at the end. And if it wants to know the measure of each angle, you just plug 10 into one of the expressions. So if I do that, 10 plus 3 is 13. So that means the measure of each angle is 13 degrees. So that is our example 1 on using the vertical angles theorem to find angle measures and to also find the value of a variable. Okay, so that is vertical angles. Next, we need to take a look at supplementary and complementary angles. Now, we have previously talked about supplementary and complementary back in Module 1. So recall what you know about complementary and supplementary angles. Complementary angles are two angles whose measures have a sum of 90 degrees. So complementary adds up to be 90. Supplementary are going to be two angles whose sum is 180. So complementary is 90, supplementary is 180. So let's go ahead and take a look at example 2, which is going to have us use vertical, complementary, and supplementary angles. Now, before we get into it, again, vertical implies that they are equal to each other. Complementary, they add up to be 90 degrees. And supplementary, they add up to be 180. Now, for example 2a, we're going to use the idea of vertical, complementary, supplementary, and linear pair to answer our questions for parts A, B, C, and D. All right, for example 2a, it wants us to use the diagram below to find the missing angle measures. So, our first one is the measure of angle CFD. We have CFD is going to be this angle right here. If I want to find the measure of this angle, first of all, do they tell me anything about the angle? They do, and they tell me that it is a right angle by using the little box. And recall that right angles equal 90 degrees. So CFD is a right angle, which means it is 90 degrees. All right, next, the measure of angle AFE. So AFE is going to be this angle right here. We could talk about this. I'm going to leave it here for a second and come back to it when we found out the others. So that will help us figure it out. So let's take a look at angle AFB. So the measure of AFB here. Okay, we can do this a couple different ways. If I take my handy dandy ruler here, if you notice when I go through and cancel out those two bottom angles, I have now created a straight line. That means that all three of these angles have to add up to be 180 degrees. So if I know that CFD is 90 degrees and that CFB, if I know that CFB is 50 degrees, that means AFB, whatever this is, it has to be this plus 50 plus 90 equals 180. So 90 plus 50 plus what equals 180. So we're going to take 180, subtract 90, and then subtract 50. If we do 180 minus 90, it's 90. 90 minus 50 is going to give us 40 degrees. So AFB is going to be 40 degrees. Again, I use the idea of a linear pair. So they form a straight line, meaning they add up to be 180. 90 plus 50 plus 40 gets me 180, thus forming my straight line. Okay, let's take a look at DFE. So DFE is going to be this angle here. And I want you to kind of focus on if I look at these two lines right here. AFB and DFE, if I have two straight lines that cross, these are my opposite angles, meaning they're vertical angles, meaning these two angles are equal to each other. So if I know AFB is 40 degrees, it means I know that DFE is also 40 degrees. Now, lastly, I need to figure out the measure of angle AFE. There's a few ways I can do this. I can use a linear pair and talk about forming a straight line with AFE and DFE. So if I know this is 40, 40 plus what equals 180? Well, in this case, it is 140. So that is one way I could find it. The other way is if I think about it as vertical, this whole thing of AFE is congruent to this whole part right here of 50 plus 90, which gives me 140 degrees. So it's a couple of ways you can go through and find it. Linear pair is probably the most straightforward way, where if I form a straight line with these two angles, 40 plus what equals 180, and that's how I find 140. Okay, part B. So for part B, it states that angle DEF and FEG are complementary. Well, complementary angles means that they add up to be 90 degrees. So they add up to 90 degrees. Now, the measure of angle DEF equals 3x minus 4, and the measure of FEG is 5x plus 6. So what this problem is telling me is that these two expressions are the measure for these angles, and that these angles are complementary. Complementary means that they add up to be 90, so it means this plus this is going to equal 90 degrees. Now it asks us to find the measure of both angles, so we have to first go through and find the value of x. So we're going to take this 3x minus 4 and the 5x plus 6. We're going to add them together and set equal to 90. So 3x minus 4 plus 5x plus 6 equals 90. Again, the reason why I know that is because it states they're complementary. This means these two have to add up to be 90. All right, so you're just going to go through and use your algebra solving skills from here. So if we combine like terms, we get 8x plus 2 equals 90. If I subtract 2, I get 8x equals 88. And then if I divide by 8, you get x to equal 11. So I know x equals 11. That is my first part. I then need to take 11, and we're going to plug it into 3x minus 4 and 5x plus 6. So the measure of angle DEF is going to be 3 times 11 minus 4. So we get 33 minus 4. And if we do 33 minus 4, I get 29 degrees. So the measure of angle DEF is 29. And then if I take 11 and plug it in for the measure of angle FEG, we're going to have 5 times 11 plus 6. So if we do 5 times 11, we get 55 plus 6. And then 55 plus 6 is going to give me 61 degrees. So I have successfully accomplished finding the value of x, which is 11, and plugged it back in to figure out that DEF is 29 degrees and that FEG is 61 degrees. If I did 29 plus 61, I would end up with 90, thus verifying that they are complementary angles. So again, complementary means they add up to be 90, so I add those together and set equal to 90. Now, supplementary, on the other hand, means that my two angles are going to add up to be 180 degrees. So for part C, it states the measure, or not measure, sorry, angle DEF and FEG are supplementary. So supplementary means they add up to 180 degrees. The measure of DEF is 9x plus 1 and FEG is 8x plus 9. And they want us to go through and find the measure of both angles. Because these are supplementary, that means they add up to be 180. So it means I'm going to take both of these expressions, add them together, and set equal to 180. So we're going to have 9x plus 1 plus 8x plus 9 equals 180. Again, supplementary is 180, complementary is 90. So if I go through and solve for x, I combine like terms, I'm going to end up with 17x plus 10 equals 180. If I subtract 10 away from 180, I get 17x equals 170. And if I do 170 divide by 17, we get x to equal 10. So I now know that x equals 10, and what I'm going to do with that 10 is we're going to plug it into each expression. So if we do 9 times 10 plus 1, I would end up with, 91 degrees. And if I do 8 times 10 plus 9, we get 80 plus 9, so I get 89 degrees. So that means DEF is 91, and that FEG is 89. And these two would add up to be 180. thus solidifying that these are supplementary and that we did our math correct. So, based off the problem, knowing that these are supplementary, they add up to be 180. So I take these two expressions, add them together, set equal to 180. We got x to be 10. I then took that value for 10 and plugged it in for x. So I know that DEF is 91 and FEG is 89. And that is our work for example 2C. So remember, vertical angles are equal to each other, complementary is 90, and supplementary is 180. All right, we have one last bit that I want to talk about, and it's helpful to talk about this in case it were to pop up on a quiz or if you see it in the homework. I really suggest that if you get to these problems that you use my completed notes or this part of the video to reference to kind of guide you through it. So you can represent the measures of an angle and its complement as x and 90 minus x. You can represent the measure of its angle, and its supplement as x and 180 minus x. So we're going to use this to answer these parts right here. Now, where this comes from. Okay, so this 90 minus x or 180 minus x. Let's say that I know the measure of an angle is 40 degrees. The idea of its complement is 40 plus something should equal 90. So its complement is the other number that you add with it to get 90 degrees. So if my angle was 40 degrees, if I plug that in for x, so that's 40, if I do 90 minus 40, I would end up with 50. So 40 and 50 are complements of each other, they're complementary, and that's where that's going to come from. So if you get to these problems, use this as a reference. All right, for D1, the measure of an angle is equal to the measure of its complement. So the measure of an angle is equal to the measure of its complement. So what that means, the measure of an angle is going to be referring to x. So x is going to be my starting point. Is equal to the measure of its complement. And then 90 minus x refers to its complement. So I now have x equals 90 minus x. You're going to go through and solve for x. So I'm going to add x to both sides. So I get 2x equals 90. And then to get rid of the 2, we're going to divide. We get x to be 45. So that means I know that x is 45. If it wants to know the measure of the angle and its complement, whatever you get for x is the measure of the angle. Change up the color. So 45 degrees. And then its complement, we're going to take this 45 and plug it in here. So 90 minus 45 is also 45. And that is the measure of the angle and its complement. Now, let's take a look at part 2. The measure of an angle is twice the measure of its supplement. So the measure of an angle is twice the measure of its supplement. So the measure of an angle is, well, the measure of the angle is x. The phrase is represents equal, twice the measure of its supplement. Twice represents multiplying by 2. So we're going to do 2 times 180 minus x. So the measure of the angle always refers to x. Measure of its supplement is 180 minus x, just like complement is 90 minus x. So whenever they ask you supplement, it's 180 minus x, complement is 90 minus x. Now again, the reason why I multiplied this by 2 is because it says the measure of the angle is, so x equals twice the measure of its supplement. Twice means multiplying by 2. So we're going to go through and multiply this by 2. We're going to distribute the 2 first. So we get x equals 360 minus 2x. If I move this 2x to the left, if I add it, 2x plus x is 3x. And then if I go through and divide by 3, 360 divided by 3 is 120. So that means x equals 120. Sorry, it shouldn't be degrees. And then to figure out the measure of its angle and its supplement, again, the angle is always what we figured out x to be. So it's 120 degrees. And then the supplement is going to be taking 120 and plugging it in for x. So 180 minus 120 is 60 degrees. So I get 120 and 60 degrees. And if I check this, the measure of the angle is twice the measure of its supplement. It's 120 twice the measure of 60. If you do 60 times 2, you end up with 120, thus verifying that answer. So if you get to these questions, please use this as a reference. Again, measure of an angle is always x, complement is 90 minus x, and supplement is 180 minus x. Okay, let the situation tell you. So the measure of an angle is equal to, so this is equal to its complement. The measure of the angle is, so x equals 2 times the supplement. Now, if you need help with those on the homework or wherever they pop up, please just let me know, either next time you see me or shoot me an email, and I'll kind of help set them up with you and kind of guide you through those. All right, so that is it for our lesson on section 4.1 on angles formed by intersecting lines. Again, key thing to remember is that when we talk about vertical angles, I'm going to pull this part up here. Okay, remember this, vertical angles are equal to each other. Complementary add up to be 90, and supplementary add up to be 180. So that's kind of the part that I want to leave you on. That is it for section 4.1, angles formed by intersecting lines. If you have any questions, just let me know next time you see me, or shoot me an email and I'll be more than happy to help. Otherwise, that is it for your video today. Thank you for listening, and I will talk to you guys later.